this part of our website, I would like to answer a question which often the students ask me before the purchase of product. They often ask me, you claim that you enhance the interest of students in subject matter. Also, you claim that you enhance their learning capability. You claim that if somebody has been out of school for several years, you can teach them the subject matter, not review them. They learn it and they can go ahead and answer the question. You even claim that even if they haven't taken these courses, you can teach them at such a short time. So how such a thing is possible? First of all, let me tell you, our teaching method came across years of research which I have done since I was an assistant professor. Long time ago, when I was an assistant professor at Penn State, they told me go ahead and find out why our engineering student quit and they change major and go to the liberal art. Is that the fault of the professor or student? I did some research and believe it or not, I found out it was really the fault of the professor, because the way the professor delivers the subject matter can enhance the interest of the student, or it can discourage them. It's not all fault of the student. Based on that, I published several papers. One of my papers was published at Journal of Engineering Education, a very prestigious journal known in the United States. Another paper of mine was published at IEEE Journal of Education, a very well-known journal known internationally. The third one was published at the European Journal of Engineering Education, a well-known journal in Europe and very prestigious journal in the Europe. And finally, one of my papers won an international award for being very innovative in and suggesting innovative techniques in teaching. It became second in the world because of the innovation which was described in that paper. So our teaching is based on those research which I have done, and I train my faculty also to follow the same method. Now in here to show you how our teaching is different than others, let me go over one subject matter called entropy. Entropy is a subject matter which usually is taught in thermodynamics to the mechanical engineering student. It is also taught to the chemical engineering student as well. Now, thermodynamics usually is taken during the third year of college, sometimes first semester, sometimes second semester. The student must take series of math and as well as physics, and toward the end of the semester, entropy is covered. Let me write down a problem and ask you to give me the answer to that problem, and then see toward the end of this lecture you can answer this or not, but you must take note and pay attention to my lecture. Here is the problem. In a thermodynamic system, suddenly entropy increased by 2 kilojoule per degree Kelvin. If the original work delivered by the system was 26 kilojoule, what is the new work? A, 29 kilojoule, B, 27 kilojoule, C, 24 kilojoule, D, 26 kilojoule. It did not change. If you could not answer this question, don't worry. I'm going to go over entropy. I'm going to discuss entropy. I'm going to ask this question again. Let's see what is the entropy. Suppose that you go to an office of an attorney and you see that his office is a chaos. All the files are on the floor. A cat is chasing a mouse, and he come and tell you, you know, I am full of entropy. I am not full of energy. I'm totally against things being in order. I don't put the files in alphabetical order. You give me your file, I'll throw it in the air. Where does it fall? Nobody knows. The next day, me and my secretary are going to look for the file. We got to work very hard to find that file and do your work. And you are thinking of yourself, is this man crazy? Why is he doing that? Are you going to hire this person to do work for you? Of course not. Because you will say that if we put the file in alphabetical order, then it would be reversible easily, because he can take that, read it, and put it back in the order. Anytime he wants to, he can find it in a second. But when he throws it in the air, it takes him 2-3 hours. He does work, but that's the work which you are looking for. If this system which he makes is organized and he makes the process reversible very easily by putting in alphabetical order, then you can move it and then reverse it easily, because you know where it belongs. But this way, it is impossible to find it. So his work is going to be much less than the work of an organized person. So you don't need him to waste his energy, and you don't want to pay him just to go look for a file. So when you are organized, or you make the system reversible, then you can do more work for your clients. Now, when the entropy increase, system become very much unorganized. And when the system become very much unorganized, the work will reduce. When the entropy increase, work reduce. So the actual work is going to be less than the work of a reversible work. If you have a system which is reversible, you can do more work in that particular system. Let me give you another example. Let's say that you buy a car from a dealer. You may drive this car for 5,000 miles because everything is the way they're supposed to be in that car. Now, suppose that you don't change the oil for 3 months, 3 years. You don't tune up the car. You don't take care of your car. The water pump is broken. I wouldn't dare even to drive this car for 20 miles. Why? Because things are not the way they're supposed to be. So as a result, the work will come down because the entropy is going to increase in this situation. Your actual work is going to be less than work of a reversible process. When in a car you change the oil in time and everything is in order, when the piston and cylinder work, piston goes and come back to its original position. It is reversible. So it gives you the highest possible work for that system. So when we go to this problem, now can you tell me when the entropy increased, which one of these is correct? Is the work going to increase, don't change, or decrease? If you answer it decrease, it's correct. So that is how we teach to enhance your interest and learning capability in the subject matter. You can get a copy of this from our website if you like to. Let me talk a little bit more about entropy so you can fully understand it. If you have an ice, when you melt it, the entropy increases. Why? When you have an ice, all the molecules are confined. But when it changes to water, molecules go wherever they want to. Where they go, we don't know. If you have a hole in here, you can never find them. But when it is ice, always you can take this ice and you say all the molecules are here. But can you do it with water? No. So if you change it back to ice, the entropy is going to reduce. But in here, entropy is increased. Let me give you another example. If you keep the pressure constant but increase the temperature of this water, then what's going to happen? The molecule go wherever they want to. It's a chaos. The entropy is going to increase. Or let's say you have a pressure on something. When you have a pressure on water, the molecules are kind of confined there. They can't go anywhere. The entropy is low. Now, if you release the pressure, what is going to happen? Then the molecule go wherever they want to, and the entropy increase. This is like, let's say that you have a Tobago, you are in Alaska, and you have 4 dogs. You are holding their leash. They are under your control. You can take work from them, and the dog can run and move you to wherever you want to. If you release the force and pressure, like this situation, now dogs can go wherever they want to. Can you get any work from them? Of course not, because entropy increased. So entropy shows us how we deviate from the way it's supposed to be, or how unorganized the system is. How if the system is a chaos, that is, the entropy is pretty high. Thank you very much for being with us. I'm Dr. Jahanian, the president and founder of AIT Expert, and I'm looking forward to see all of you in our webinar classes. Thank you.